Stoichiometry. Well, stoichiometry is essentially the way you find out how much reactant you need to make an amount of product, or how much product you can make with the amount of reactant you have. In stoichiometry, you'll be relying on knowing how to convert from units of a substance to moles, so that you can use the mole-to-mole ratio. Basically, you'll be setting up reaction equations and then doing algebra to them. For example, stoichiometry involves converting from moles of one substance to moles of another. An example question is this. How much hydrogen gas is created when 6.0 moles of sodium metal reacts with an excess of water? To solve this, first we set up the reaction as an equation, then we predict the reactants, and finally we balance, like this. With this equation, we can now finally do the conversion. We start with 6.0 moles of sodium metal. By balancing our equation, we know that for every 2 moles of sodium, we create 1 mole of H2. We multiply this by our starting mole, the mole-to-mole ratio, and then we get a result which is 3.0 moles of H2. This concept also extends to doing calculations with other units such as grams. Take this question for an example. How many liters at STP of hydrogen gas is created when 60.0 grams of sodium metal reacts with an excess of water? To solve this problem, first we must convert our starting substance's units to moles, like such. Then we can create and balance the equation given by our reaction and use our mole-to-mole ratio to convert to moles of hydrogen gas like this. And finally, we want to convert back to our desired unit, which is liters. We end up with 29.5 liters of H2 gas. But wait, we've been making some unfounded assumptions. We live in real life and things are more messy here. Unfortunately. We've been assuming that our reactions are pure and that all the reactions are 100% efficient, but that is not always the case. Let's talk about excess and limiting. Imagine, if you will, that you have 12 flower pots and 4 flowers. How many flowers can you plant in the pots? The answer is limited by the amount of flowers in this example. No matter how many pots I have, I can only plant 4 flowers. In this case, I will have 8 excess pots. No matter how many pots I have, I can only plant 4 flowers, because the flowers are limiting the example. This example extends over to our reactions as well. It can be a little more complicated to visualize, though, as everything is measured in moles, not amounts of flowers or pots. In this example, we have 10 grams of magnesium metal and 500 milliliters of HCl. How can we find out how much hydrogen gas is made? And how can we determine which reactant is limiting and excess? Well, first, we must convert everything to moles. Then, we can use the reaction equation to help determine which reactant will be excess. To do this, I like to convert both units to the same by using the mole-to-mole ratio. In this case, I convert the 0.6 mole of HCl I have to see the equivalent amount of magnesium metal I would react with it to find that it is less than the amount I have, meaning that HCl is my limiting reagent and the magnesium metal is my excess. Finally, knowing these facts, I can do the calculations and find that I would create 7 liters of hydrogen gas and 3 grams of magnesium metal would be left as excess. The final topic I'm going to briefly cover is percentage purity and percentage yield. In essence, these concepts are both just asking for fractions. For percentage purity, you're looking for what fraction of some impure substance you have that is the pure chemical you want. So, for example, if you have 20 grams of 80% pure calcium carbonate, that means that after doing some algebra, you'll find that you only have 16 grams of pure calcium carbonate. Percentage yield, on the other hand, is just looking for how efficient your reaction is. This example is a bit longer if you want to read it, but basically, if you react 36.5 grams of pure HCl with an excess of NaOH, and you only receive 48.4 grams out of the 58.5 grams that you expect, then that means that your reaction is 82.3% of it. And that is a brief overview of percentage purity and percentage yield. And overall, that was just a brief overview of stoichiometry.